Welcome to another INTEA breakfast. This time we will talk about artificial intelligence. This is a rather hot topic in the sense that every platform, every learning management system, some tools now are adding AI to the list of their features. The question is, what is AI? And frankly, this is not something that we will bring to you as specialists in AI. I would say that it's a rather layman's perspective where we decided to find out for ourselves what AI is, try and find some cases where it actually already works and can be used, or what we can expect in the near future. And also hear your opinion, whether you're skeptical of this technology, whether you understand that at all, and kind of be on the same terms with something that is so much discussed, right? So let me share my screen and we'll take it away. Right, as usual, we used a lot of movie slides. So if you want, or you're bored by what we're telling you, you can play this little game of name the movie. The first slide is not a movie. It's a coffee, like this one. And kind of where I would like to begin is actually here. In 2016, I think Elon Musk first kind of came out with this idea at one of the conferences and has been reiterating this ever since. He told that AI is humanity's biggest existential threat. Not like it's a technology that can be abused or technology that can endanger a lot of people and so on, like nuclear technology back in 1940s. But this is existential threat, something that can wipe us out. And a surprising number of very smart people agreed with him, and including Stephen Hawking at that moment in time, for example. And it's a very interesting perspective, right? Especially from someone who is at the forefront of technology. So it makes it just more interesting to
understand it, I think. That's right. and form your own opinion in the end.
Exactly. Right. Because the opinions are very, very divided about this. Right. So if we look back, I mentioned 40s right now. This is actually where a lot of great technology has begun. Artificial intelligence kind of as a notion also appeared in the 1940s. And we will not go into the definitions too much because there are people who wrote their PhD thesis actually on the definition of AI. That is absolutely crazy. In general, one of my favorite ideas about AI is that an intelligent machine or AI is something that does a job that we would say is intelligent if it were done by humans. That is as vague as it gets, but it doesn't get any much better than this and kind of explains it, right? So, intelligent, it kind of does something like a human. It can play chess, for example, or play checkers, or play Go, or it can understand meanings in text and kind of read, or it can write text or write music maybe, or it can take your e-learning course and maybe add a quiz to it, and that quiz would pretty much be like something a human could create out of this. That's the idea. And today, we don't really hear AI that often, especially in technical settings. We talk about machine learning and deep learning, especially in recent times. The question is what it is, what's the difference? So we will look at this a little bit and understand kind of the meaning behind those terms, because again, on one hand, they're used interchangeably, on the other hand, they are used kind of to promote and market products which not necessarily even have that technology inside. So let's try and wrap our heads around that. So if we typically talk about programming computers, and this is another cinema frame as well. So if we talk about programming computers, it's kind of very straightforward, right? You give a computer instruction and computer follows it. You can give a lot of instructions, they can be very complex, but the computer follows them and you kind of understand what's going on in there, and you can trace what's happening every step of the way. The problem is, if you want computer to do very complex things like things that our brain is capable of, like recognize text or from an image, or recognize a cat from a dog in an image, something that's very easy for us, it's incredibly difficult to describe in classic programming terms. And this classic programming has been around for a long time. This is an automated Loom, something that people use an example of. And Loom is something that you use to create textile, right? So, and to create patterns in textile, you can pre-program those patterns and then just follow the program. You can, in 1800s technology, you can also put a human in the middle of it because it's the easiest way to actually power this thing. But, this is about, like, normal programming is about giving straightforward commands and the computer just follows them. And again, the problem is that, you can't, it's incredibly complex if you want to do something as simple as recognize a cat from a dog. So people turned to 1940s, people turned to the human brain and tried to simulate that. And surprisingly, it proved very fruitful. And that technology is still at the heart of every most complex algorithm in machine learning that exists. And that is called neural networks. Neural networks is, a network of neurons, of cells in our brain. And to understand how it works, we have to kind of remember, go back to biology and understand how the brain works. And the brain works very simple. This is a neuron. I frankly don't remember which part is axon and which part is what, but it has a head and a tail, right? It suffices for me. So, and it can send a signal, almost an electrical signal, from the head to its tail. Now, if we take a few of those, they can form chains. And they can send signals from one to another. So one neuron activates, sends a signal to another one, that one activates, sends a signal to another one, and so on. That's pretty cool. What if we add more neurons? They actually can form networks and they can send signals here and there. And the interesting part is that it does not just work as electrical network where signal does not change, or it doesn't work like binary computing where the signal can be or cannot be. So it's 1 or 0, yes or no. It's actually more complex because neurons can change the intensity of those signals, kind of assign coefficients to them. And then when 2 or more signals come to the same neuron, depending on those coefficients, it will emit its own signal, which will kind of depend on those 2. And sometimes if you don't get a signal from here and you get from here, the one goes there, and so on. So it's a little bit more complex than just, current running around wiring, but not unlike that. Now, how do we replicate this in the machine form? And that's very easy. We take one neuron and we replace it with a formula. Something like x equals y something happens to this y. All right, so it can take an input, the y, and it can provide output. It will give you the x, kind of like any formula does, or any function in a computer does, or computers in general. Now, if we take a few formulas, one will provide you with y based on c, the x, and then we'll give y to this one. This one will provide you with an x. This one will provide you with the z based on the x, and so on. And then we take way more such formulas, and they are essentially linked into a network where they provide values to each other. And again, there's coefficient involved. So one formula gets 2 things, and then 2 inputs, and then assigns coefficients to them. And you can play around with those coefficients to determine what the output is. And it does not make much sense, but it doesn't have to, because what you're interested in is what you input in the whole network of these formulas at the beginning and what you get at the end. In the middle, there is a lot of coefficients that play around with data and come out with something, right? And that is a brain, but it's an empty brain, kind of like a stupid, unlearned brain. And when we talk about machine learning or deep learning, we
start with such a brain.
Yeah, we essentially start with a simple empty brain, and then we have to train it. So how do we train it? By the way, what we just came up with looks a lot like a real neural network. This is a screenshot from a software which deals with neural network programming. So I'm not entirely I'm not far away from the truth in that sense. So how does it learn, right? And it learns in a very kind of straightforward way, something that you could expect. So the idea is that you start by giving it some data. For example, you can give such a network a folder full of pictures of cats and dogs. And you actually know it's labeled data, right? You know which are cats and which are dogs, but the computer doesn't. So you give it the pictures and it tries to sort them, just maybe randomly or almost randomly. It assigns some coefficients and tries to sort, cats from dogs, and then provides you output, and then you actually compare that. Is it a good output? Was it correct? No, a lot of cats were recognized as dogs and vice versa. So you try and change those coefficients, again, almost randomly. For now, for the sake of simplicity, we can agree that you try to shift those coefficients left or right a little bit and see whether the recognition has improved, right? So you slightly adjust that and do it again blindly without knowing which are cats, which are dogs, and then you create some output and you see if it became better. If it became a little bit better, then you're going in the right direction. If it became a little bit worse, you're going in the wrong direction with your coefficient. It's like hunting for the correct answer where you actually don't know the correct answer when you're trying to solve a puzzle or solve an equation. Maybe in graphical form, you try to kind of zoom in on it by changing some things and seeing if it works or not. Kind of like learning, right? And you do it, a lot of times, and then at some point you achieve, like something like 98% accuracy in telling dogs from cats, and then you say, okay, my coefficients are excellent. What I can do now, I can actually take a new data set, the one where I don't know whether it's a cat or a dog, and feed it to this network, and it will tell me if it's a cat or a dog, right? Or it will tell me if there is a face in the picture or no face in the picture. Or it can take a text input and tell me whether the person who wrote that text was trying to say yes or no, because it says okay, or it says I agree, or it says something else. So it recognizes meaning from text. Or it can do pretty much any other task. Like generate a face out of random noise, because the way that deep fakes actually work, that's also very. We will not go too deep into the deep fakes, but that face generation is actually funny. There are two competitive networks working alongside. So one is trying to learn how to generate faces out of random noise by adjusting coefficients until that random noise actually forms something that looks like a face. And the other one is trying to compare that face that it formed to the face that we're trying to replicate, which it already knows and tells that one whether it's good or not. It's like learning in university when you actually learn in pairs, and one guy, that's actually how INTEA works at its core. One guy provides ideas, the other guy tells, this idea is good or bad, or better or worse. Are you going in the right direction or not? And essentially, two networks just compete in creating faces and then telling that face is no good, and then go ahead and create a new one. And they do it like 1 billion times per second on a very complex machinery. And in the end, it is able to simulate a face which looks like a real thing. That's amazing. So yeah, right. So you receive input, you provide output, see if it's good or bad, adjust slightly, and do it as long as it takes until you do the adjustment. So the output is excellent, and then you can work with the new data, which is unlabeled, which you don't know, which is the whole point of you actually trying to achieve. And of course, there are a lot of, in software, there is a lot of pre-trained networks. So if you're building, let's say, an automated gate where your AI has to recognize numbers on a plate, you can take a pre-trained thing and it already knows the numbers, kind of like a human that you employ. And in their CV it says, I know numbers.
Numbers.
But again, it might not know Arabic number, like not Arabic, but numbers where if you've been to Saudi Arabia or Kuwait, they have very weird numbers there. The actual figures on the number place, it might not be trained for that. Just like I'm not, I wouldn't be able to recognize that, and so on. All right, so wave your hand if it became a little bit clearer that how that thing works to anyone. Or did I confuse the hell out of it? Yeah. Let's say on a place on a scale from -10, where it became much worse than before, to +10, where it became much better than before. How do you feel about AI at this point compared to?
We get a +8.
Okay, +5. Excellent.
Okay, so Sergey did not confuse you entirely.
Yes, and I'm happy that you trust us that any of this actually is related to reality, right? So yeah, that is actually how you train networks to look at a million faces and tell if it's a surprised face or it's a sad face or it's a happy face and so on. You train it on 1,000 pre-labeled faces, the ones where we actually know if it's a surprise or not, and then you give it new faces and it actually uses this previous experience. And that experience is essentially just a set of coefficients that process pixels. And that is amazing, right? That's what's amazing about AI. You are not giving it instructions on what that face looks like. That eyebrows has to be this high, and the eye should be this wide, and the lips should be this, and so on. You actually just feed data into it until it's kind of starts making sense of it. That's incredible, and that is what is so great about this technology. And of course, to get this labeled data, and you'll see why it's important when we get to actual training part. To get this labeled data, you have to get it from somewhere. So if you're training, for example, autonomous cars to tell a road sign or a street sign from an advert, for example, you have to get 1 million pictures of street signs and 1 million pictures of adverts, and make sure that these are street signs and those are adverts, and then you can actually train your machine to tell street signs from adverts, because it needs to do so to be actually driving on the road. So who do you employ to do that? And if you're Google, you can employ everyone. So every time you meet a CAPTCHA like this, when it tells you, can you show us traffic lights in this?
Traffic lights, boats, bikes,
people, crossings, street signs, anything. Buses and so on. It actually tries to create this labeled data set for its networks to train on, and we're actually helping it do that.
So you're part of this in your everyday life as well, right? It's not somewhere far away.
Yes, and interestingly enough, just as humans can make mistakes, computers can make mistakes as well, and even absolutely in the way that our minds play tricks on us when we see something, and you've probably seen a million of various.
Is it an ugly woman or a beautiful woman?
This ugly old woman versus
young beauty or something.
Young beautiful woman, that one, or is it a blue and black dress versus a white and gold dress, and so on, like a million of those things. So our mind can make mistakes in the same way that AI can make mistakes, and that is
that's a good mistake.
So the story is that UK police is trying to monitor social networks to detect people who distribute pornography, and it analyzes pictures for pornographic content, like does it have naked people in them? And it has detected a surprising amount of sand dunes of deserts, which to a computer network look like a naked body. Why? Well, you can try and guess why, but the funny thing is that computers, they don't act on instructions. They act on reading a million pictures before, pictures with bodies and non-bodies. It turns out that they are not trained well enough to tell a naked body from a heap of sand. So yeah, they can make mistakes, and those mistakes depend a lot on what they have been trained on. So you have to keep that in mind. AI is absolutely not unmistakable. Unmistakable.
Something like that.
Right. So where it's applied, and this is our step into the training and development area already. So surprisingly, artificial intelligence is used in the stupid jobs that people don't want to do. Right. So in general, it can recognize patterns in data, for example. Right. So it can look at the crowd, and by looking at a million faces before, it can find a new face that exhibits a million faces which we have labeled as bad guys and good guys. It can now look at random crowds and recognize bad guys in crowds, right? Because of we don't know why. That's the interesting thing, right? So if you were training a human, you would try to tell it that this is how, why this is how the person moves or looks or behaves or dresses or stays in place or moves about and so on. But for a computer, it's just I've seen a million crowds, I've seen a million bad guys, I just know how they look. I can never explain you why though. It's like they just know.
I know it when I see it.
I know it when I see it. Exactly. So this is how AI works. It can also understand images and videos and speech. It's, for example, if you upload a video to YouTube, it's analyzed and the speech is extracted from that video and converted to subtitles. And those subtitles are now searchable. So now Google allows you to search inside videos, which your learning management system does not necessarily allow you to do. It can understand images, right? If I go to my Google Photos, and Google, of course, is one of the big AI companies today. If I go into my Google Photos and say, I want to find my son with a cat, I will find exactly images where there's my son, there's my cat, or a random cat mostly, and so on and so on, right? We talk to computers and phones and Siri and Alexa and whatnot in natural language, right? We don't need to issue specific commands with our voice. We just ask her and she does it. And computers can extract meanings. That's actually kind of the forefront of that thing, because it's one thing to understand that I said yes or no. The other thing is to understand that yes actually means yes, and that okay means yes, and that
which is not necessarily true.
Which is not necessarily true in all the contexts. So you need context and so on. And that is just a binary yes/no thing. What if you asked me to describe something? Can you guess from the description what that is, and so on? And computers can actually do that. And there are already things like where you can create designs by describing what you want. You can say, hey, I want a page with beautiful flowers and a button that says subscribe, and leads to a form where you have to submit your name and email, and that goes to a database. And computers can actually create a whole design. So a lot of people will be out of work. And of course, it's not just about understanding and recognition, it's about generation, right? So currently this competitive networks that I explained before are kind of the it of generating stuff, and computers can generate text, for example, based on a certain guideline. You give it like one paragraph of text, and it generates something along those lines. Or you can give it a lot of text and it generates summaries. It can generate images, new faces that have never been before. It can generate speech, mimic tones and accents and whatnot. It can generate videos, moving pictures and so on. So actually creating content is now easier as well, especially if it's like, let's say, stupid content, right? Something where you have to read a ton of text and just provide very brief summaries. And it's something that, you would hate doing, but computer can do it 24/7 and not get tired. And yes, they do it very quickly, mostly, and they can do it at scale. They can do it faster and more of it than 1,000 people or 10,000 people or 1 million people and so on. So every time you think like, this is a stupid job, you can also think, AI could probably do that. So artificial intelligence is very good at doing stupid human things. All right, so where does it go? And previous slide was also from a movie as well. Recruitment, right? We will start with the HR process kind of at the beginning, where we recruit people. That is one of the hottest areas for artificial intelligence. And what it does, like I said, high volume monotonous tasks like application screening, right? You receive, it's actually crazy. We're now hiring at INTEA. We posted job ads on Facebook and some of them get spammed. Maybe something like key account manager prompts an alert and shows up in too many people's feeds, and a lot of random people from all walks of life and all areas of the planet start applying, and that is complete junk in terms of what we're looking for. But you have to screen them manually, right? What if I had a AI that would, just be trained on telling what's good and what's bad in terms of applications? If it's in the wrong language, at least, can you just delete it and not show it to me? Right now, I have to open it, see it's in the wrong language, and remove it. Right? Anything that, as an HR person, someone who does hiring, you spend a lot of time on actual scheduling interviews, right? So, and just stupid work like answering questions. Hey, can we move this to Tuesday? Is there any time available on Friday? Can you do it on Friday? And then you have to ask this guy and that guy. Hey, and then can you put into your calendar and so on? And it requires human work. It's not just a program or a script that compares to calendars. It actually you need to talk to people and say, is it all right for you and so on. And airlines are already using this successfully in most cases. I think data from a couple of years ago was that more than 88, something like 87% of all online interactions with chatbots are not actually involving humans on the chatbot side. And airlines are very good at it because, again, it's something that's easy to learn, right? You're not talking about your life there, you're talking about specific things. So AI works in scheduling. Digital interviews, that's actually an interesting one. On one hand, if you have to talk to 500 people on video and you have to understand whether they are polite and charming and smiling, or whether they are when they see a question of describe your previous employment, why did you leave? And they start telling you, can you tell from their behavior that they are very unhappy about what happened despite what they're saying and so on? Computers are actually very good at that, and they're very good at detecting facial expressions. And a lot of people go as to say that they're very good at detecting emotions. And that has actually been disproved recently, right? There is a big study which explains that emotions are not, that facial expressions are not very well correlated to emotions. And it studied both AI and human reactions. Like, it gave a lot of facial expressions to people and ask them to tell whether that person is sad or happy or surprised or dubious or trying to lie and so on. And people actually failed remarkably at that, just like AI failed at that. So
because in the first place, who was tagging those pictures from which the AI learned? It was, again, humans. So,
yes.
So
that is exactly true. That's the bias part of AI networks, right? So digital interviews, on one hand, can be fun, but you don't have to expect a lot from them. And there's a lot of overpromise in that area right now. There are companies who promise you psychometric evaluations from interviews based on AI. So it seems very compelling that I can just ask all 2,000 of our employees to talk to web camera, and then in a matter of minutes they receive their psych eval instead of paying for 1-hour interviews with a psychologist, and does not work as well as you might expect. And again, it may include a bias, and the bias is essentially about what this label data. Remember cats and dogs? Imagine that someone who was preparing that data decided that any small dog is essentially a cat, right?
Yeah.
Like a dog is a real dog.
Like define a dog.
Define a dog. Yeah.
Somebody's smaller than
this yes. Let's say someone messed with your data and thought that small dogs they are like cats, and then AI will just inherit that bias. So that's a problem. And also, let's say someone did a psychometric evaluation on Walmart employees. There's like 1 million Walmart employees in the United States, and they trained their network on thousands of those and then retrained it using new data, and that's all excellent. And then they come to Europe, to Germany or to Latvia, and they try to apply that to us. And we Latvians might have different facial expressions than people who work in Walmart in the United States, and those results can be a little bit off. And then if you try to train that network, where do you get millions of Latvians to train on?
Basically everyone in the country.
Yeah, and then why do you need AI? You've already spoken to everybody.
Yeah.
So that leads us, like, I think I have it in like the end of the presentation, but I'll tell you now. Anytime someone comes to you with a solution and says it's AI based, the correct question to ask them is, what's the data set that it's trained on, right? And if they, either they describe the data set, or you find out that there is no data set, and that is not AI, it's just a set of rules and statistics, like always happens in recommendation services, which we'll get to in a second. All right, so the next movie is human capital management, right? Like run-of-the-mill everyday HR. And that thing is written by AI today, and that's actually great. So what if we could analyze huge amounts of data, just like we're looking for bad guys in the crowd? We can identify employees on their way out, right? So what if someone starts writing letters or emails after 6 p.m., right? Or doing Zoom calls after 6 p.m. Maybe he's doing interviews. We can just try and find...
taking random spots for personal stuff throughout a couple of weeks, like something like looks like an interview, like he's going somewhere to be interviewed.
And again, we don't need to know that.
The machine will know.
the machine will know, and we will not know exactly how it knows, but it will. That's again the beauty and the scary part of it, because we can't predict what it tells us, and we can never be sure that the next guess it does is just as good. Maybe it just goes haywire, like the hell from a few slides back, the red eye thing. And again, in a similar manner, we can measure and predict performance, right? So what if we analyze people who work as bank branch employees, and then we take a data set from those people, look at those people who became branch managers, look at for the best branch managers, go back to their historical performance as cashiers, and then figure out how we connect their performance as a bank teller to a branch manager, right? So, and it might turn out that a network, computer AI will identify things that we don't expect or we don't really understand, and we'll find a correlation in all this data between, and this is where we actually go into data, the big data stuff as well, between how much time they take at the water cooler, right? And then, and then it turns out that people who take longer time at the water cooler, for some reason, are great managers later. Why, we don't know, but it just works, and we can actually use that, right? Again, same thing as before, help desk, right? A lot of HR is about solving simple problems like, where do I submit that? Where do I submit this? Can I ask for a vacation? I need this paper signed and so on. Again, AI is very good at helping people out without involving your time, but again, does not come without challenges. So the question is, when we're measuring something, are we measuring the right thing? For example, we can optimize for speed of client service, right? And we can say, okay, our excellent employees are the ones who do client service faster. They can serve more clients per day than others, and that's the KPI sort of. And then we find out that people start, we start selecting people using AI. We start selecting people who are rude and unwelcoming, and they just try to get the person out of the store as fast as possible with the purchase, but still not very happy. And we find out that we're optimizing and measuring on the wrong thing, and the right thing would be something like customer satisfaction. So and AI does exactly what you tell it. There is a great TED. There's a great TED talk on weird AI. So you can look for weird AI on TED. And it gives you a few examples of where artificial intelligence solves tasks literally, right? So one task was to create a bipedal, so a thing with 2 feet, 2 legs, robot that would navigate difficult terrain. There's hills and rivers and whatnot, and it has to create this little model of 2-legged thingy that walks across it, and it can the AI can play around with the motion of the walk, with the form of the legs, and so on. And they did not, the people who created it, they did not think to limit it on the length of those legs. So the AI ended up creating a bipedal thing, which is this big, but it has such huge legs, so it takes one step across the whole terrain and is on the other side immediately.
Makes sense.
Did it solve the problem? Yes. Now, then the other time they actually tried that. It created. They expected it to actually walk, but it created one leg that was very, very long. So it just stood on that leg and just fell over. And when it fell, it was on the other side. Again,
problem solved.
Problem solved. So AI does the literal thing. That literal thing is unexpected and weird a lot of times. So you have to really be careful about those things, especially when the implications can be very costly, like in HR. And then, of course, there's ethical part. AI only works with data. Gathering and collecting this data is a big question, right? We, as employees, are not the property of a company. We expect a certain amount of personal space in the company. We don't expect cameras, for example, to be everywhere. And even if it's not about trust or mistrust, those cameras can be, just for data collections. We can actually, want to see how you people move about the office,
to predict something.
To predict something. It's all for everyone's good. But, people might not like that. And it's a huge question whether that camera should be in every room of that office or not, and so on and so on. So there's that. All right. So another part of HR landscape where, again, training and development is increasingly involved. And that is something that I think we should speak at some point at the breakfast. It's how training and development is not about training kind of before the fact, but rather about supporting people and helping them do their job in the moment. So performance support with AI, it's something that we see every day in our lives, but it's also entering workplaces as well. One thing is writing and communication support. I keep hearing from Raivis how I have not employed it myself yet, but Raivis loves Grammarly.
Yeah, Grammarly is the thing.
Why?
Why? Because it corrects me on the stupid mistakes. Because it does the job that otherwise I would have to give to a colleague, like check my text. Have I not forgotten any commas, or anything there?
Yeah.
Or question marks, right? So it does that stupid work, and I don't have to involve my colleagues who have to be doing something more intelligent at that point, right?
I only know about Grammarly from the ads that it keeps bombarding me with. But what I like about it, that it's really AI-based. It's one step from this dictionary-based spelling thing where you could write a word that's in the dictionary, but it's the wrong word in this context, and it would not highlight it, right? You probably know examples of that. Now, Grammarly is better because it understands the context of what you're writing, and
can actually erase your context. You see that when you're writing an email, it shows you the emotion of that email.
Okay.
And at the same time, it asks, is this emotion correct? So it's machine learns as you go. So you kind of get value, but you also provide this data to the data set. So it's constant improvement, and that's brilliant. It's not like the old days in Word where it shows you it's incorrect spelling, and you're like, come on, this is correct spelling. You just don't know that term. I mean, this is
something like this.
Yeah. So
what I use Gmail. Gmail actually has read all my emails from all the previous years, and it now knows the way I talk and the words that I use, and it suggests, provides suggestions as I type, and sometimes for simple emails, those emails are almost automatically generated.
Yeah.
I just confirm. I say dear. It inserts all the names, and then I say thank you for, and then the last phone call, and then I say talk to, and they're like talk to you next week, and then I say best, and it says best regards, Sergey. And I'm like, okay, should I
next time do it all yourself?
Yeah, should I even be involved? Right.
Yeah.
So, and it's not just about emails and communication. The same thing happens in chats, for example, where we communicate in team, like Microsoft Team and other things. Same thing happens with, let's say, CV writing. Same thing happens with presentation building. So right now there are softwares which at least they claim to have AI help you create slides, right? So you just type out, this is what I want, on this slide, and provides you templates and your layouts, and they change and they shift about and so on. Those things, I'm not really sure how much AI exactly is involved in there. Where's the data set? Where are the million presentations they've learned from? Or I would suspect them from just having a lot of nice rules about how things should be laid out. But still, again, this is coming into our life and help us, design better things faster. If you start typing, or you open your CV in Word, Word today will detect that you're writing a CV and will provide you tips on that. And try to correct your language as appropriate for a CV and so on. Again, it knows, it makes your job faster, and instead of, it kind of takes away from the training part, right? You don't need to give people the e-learning course on business writing or e-learning course on how to create your CV. Instead, you can actually employ a machine that fixes it in the moment.
Because the interesting thing is that while there is machine learning in the background, you as an individual, for example, with, I don't know, not exactly the best English grammar, right, you will learn from correcting yourself and agreeing with those corrections. Right. So it will definitely boost your skills. So it's not like a machine doing that and you are not learning from it at all. That's right. And
I look at the chat. Up in the Air was absolutely correct. Yeah. Office Space was absolutely correct. Right. Mission Impossible now, you recognize Tom Cruise. But
it's not the only movie.
It seems like it, all seven missions. Yeah. But I think that's actually Minority Report. It's about. It's a sci-fi movie about predicting future, actually.
Yeah.
Smart assistants, right? Yeah, that's another thing that helps a lot in our everyday life. Calendar scheduling. I write an email. Even small things. I write an email and I say, please find attached. You don't attach something, and it alerts me. Like, are you really sure you want to send this? It seems like you mentioned an attachment.
Google does that today,
yes,
I think.
You meant. Google does. Like this is where we learn from. So have you attached an email and so on? Again, the question is whether it detects it just based on the word attachment, because that's not AI, or it actually has read a million emails with attachments and without attachments, and
he can decipher it
he can decipher it from the context, right? Because again, it has seen billions probably emails with attachments and without attachments. Navigating sea of information. Again, another thing that's
takes a lot of time and effort and can be done in minutes by machine, right?
Again, can you please find me, like I said, can you find me pictures of my son with a cat? Likewise, can you find graphs on employee performance for the past 15 years instead of me going through heaps and heaps of information
and figuring out which keywords to use to get to that thing? I mean, that's the most frustrating thing.
And AI can just tell it from the pictures, because all those pictures look a little bit the same. We don't know how, but they do. Again, and it borders on magic sometimes. So the challenge why it's not adopted widely right now is information security. If you talk to your IT about, hey, can we give all the communication in our company to this server somewhere, and it will churn it and create some rule sets and will help us, they will be very, very alerted. And running this thing in-house is almost impossible, because companies who provide this type of tech, they will not allow for it. So that's kind of something that puts brakes on the whole thing. And also, interestingly, people, and it's in general about performance support, people are complaining about performance support because they are overperforming and they're burning out, right? Sometimes doing that stupid thing like proofreading your colleague's email is a necessary break in your work. And if you take this away from people, there is no breaks and they start burning out, right? So when we are absolutely at 100% efficiency, that's a little bit like pedal to the metal, and that can be rather hard. And that's already happening. For example, that's already happening in Amazon warehouses, where robots are replacing humans, but the remaining humans, they have to compete with robots basically. And robots don't get tired. They just keep bringing you boxes, and you have to package those boxes. And that robot is not your former colleague who was just carrying those boxes. That colleague would take a smoke break from time to time, right? And that robot is just, it doesn't do that, and you have to keep up with that, despite the fact that your job is so difficult with those different types of boxes that it will probably never be automated. But the speed of that job, thanks to the robots around you, has increased so much that people get repetitive strain injuries and other health problems from that. Simply because everything around them is so robotized, artificial intelligentized, and so efficient. That's quite scary. Right. Now, the last and our favorite part, learning and development, right? Learning and AI go hand in hand in two major directions today. Again, we're not fantasizing about things in the future. We're looking at things that exist today and solutions you can look for right now. One is, of course, content curation. Just like Netflix and YouTube can suggest you the next video that you will like based on the content of those videos, and based on the million of people who have already liked that video and they before looked at videos like yourselves and so on, it can suggest you content. So same thing can happen inside your learning management system, not without a problem, because for that, well, again, you have to have the data set and historical data to train on. Two, you have to have enough activity and enough content for that to actually be meaningful. And three, a lot of companies who will sell and try to sell this to you will actually have rather basic statistics in place of machine learning that does that. But the good thing is that statistics is way more predictable. So this is why they're trying to do that, and also cheaper in many cases. Automated grading, right? So you don't have to resort to tests. It's very easy to automate a test, right? It's essentially what it is, right? Choose A, B, C, or D. D is wrong, C is correct. That's easy. What if you had to write an essay, right? Can we grade an essay? And it turns out that yes, actually we can grade an essay, and AI will grade it, but the way it grades and tells, good essays from bad essays, and again, someone has to teach it, it has to learn from somewhere, can be very, very weird and unpredictable, and you have to be careful.
I'll be glad it's not my former English teacher who has been learning this machine, because nobody get a pass.
Yes.
So it's again human. It's again a human humans somewhere there. So it's as good as those humans are.
Right, but on the basic level, it can easily tell you something that's totally bad, or and then you can work with it, and so on. You can take a load off, but just dismissing things like spam filtering, pretty much in that case. Just-in-time context-based learning. Back to the performance, AI is very good at understanding context. It understands the context of my email and suggest things that I could type, and surprisingly correct most of the time. Same thing with learning. Can I look at my calendar, see what I'm about to do this week, and suggest some negotiation learning if I'm meeting with a lot of clients. If I'm about to go to a certain type of training, or go on a business trip, can it suggest some IT training, for example, on securing information while out of the office, and so on and so on. You can actually understand context and provide.
The other real life example, and again, I don't know how much AI is there. I have a suspicion it's just a lot of algorithms that it monitors your Teams chat, and based on that provides you content suggestion. But I'm again a bit suspicious that it might be just some algorithm saying, he said, I don't know, work safety, so Google for work safety, and bring in the most popular kind of resource on that. So which might not be it does not, in that case, there is no context to it. It's just keywords, right?
Absolutely. Content assistance, that's actually great. Just like writing emails, you could be writing texts. If you are writing a script for a course, for example, there is now software for writers, which helps you keep the same thesaurus, helps you monitor the quality of your text, and really amazing things. And also creating other types of content. I will show you something that really amazed me, but the content like in media production, where you can create videos. I have recently spoken to a company. There are guys from Moscow that I know. They're doing deep fake videos essentially, and they did a project where they couldn't fly out to film a lecture for a video lecture, and that guy is famous inside their company. The company is Gazprom, so there are experts inside this gas production company that everyone knows kind of, and they know something, and they had to film a lecture with the guy, but they couldn't fly out to him because of COVID restrictions. And they filmed an actor and took the guy's face and took the guy's voice and put it on top of the actor. So the guy was also talking, but they changed his voice in such a way that it sounded like that guy, and they replaced his face. And that's incredible. And it's already, it's being used, and it's absolutely crazy. So if you want your CEO, for example, to narrate all your courses from now on, you can, right? But then again, there's a question of if previously even getting approved a single quote by a CEO on the front page of an important course was difficult. Now imagine approving using his face for an hour in some sort of lecture which someone else wrote, and so on. But those things already work, and deep faking is just one of the things that you can use. And simulations, of course, right? You probably all know BrainStrack, where you can talk to virtual characters, and you can try and sell them something, but it's all based on pre-programmed paths, right? So you click this button or that button, and that character reacts in this or that way. What if you could say or write something which would influence what the character would respond? There is a program called Dungeon AI, or maybe AI Dungeon, and it's a role-playing game where you can play as a knight or hacker or something in a cyberpunk world, or a knight in fantasy world, and so on. You actually type what you're doing, and the program creates kind of the content for you. So you type, I go into a wood, and it tells you, okay, you enter a dark forest and it looks scary, and so on. That program is learned on 11,000 books, fantasy books. And it read all that fantasy, and it can create fantasy on the fly for you, and it can understand what you're trying to do. And it's, if it creates a dragon for you, you can say, I want to kick that dragon in the head. And it says, okay, the dragon jerks their head away and breathes fire on you. And so on. It's incredible. It's like a game that creates itself on the fly for you. That's amazing. And that thing is coming to business as well, maybe to BrainStrike at some point. All right, this is a quick example. You can see how camera captures face of a person, recognizes that face, and animates a character in exactly the same way, or this, right? Again, there is a neural network which can decipher what is happening in that image. You don't need any markers in there. You don't need any equipment. It just looks at the image and can tell, hey, that's a head. Hey, that's a smile. Hey, those are hands. And then apply that to a character. And the crazy part is that character is also not kind of pre-programmed, so that it's just an image. Again, we don't know that those are hands and that is faces. It's recognized on the fly, so you can take any other image there and just animate it like that. It's absolutely crazy, and again, speeds up production, creates media that would take a lot of animation time before. All right, so to finish off, I would like to go back to 1940s to a guy called Alan Turing. That is not him, that is Benedict Cumberbatch playing Alan Turing in a movie. And Turing, when in 1940s people started thinking like, what's artificial intelligence? He proposed this idea that the machine can be deemed intelligent if a human cannot distinguish it from another human being by using the replies to the same questions. So if you're interviewing someone and you can't say if it's a person or it's a machine, including them making mistakes, for example, then that machine can be called intelligent. Again, not sentient. We're not talking about sense or soul or anything like that. Not even intellect, but intelligence. And that is where we already are, definitely are in our lives and in our technology in the world. And it's entering the workplace, it's entering the HR, and hopefully you are a little bit less confused and a little bit more excited about this than an hour ago. Thank you for joining us. Follow us on every social network that we have. This recording will be on YouTube, hopefully today. Find INTEA on YouTube and subscribe. We're trying to grow the channel. All the breakfasts are there. If you like this, give us a thumbs up. You can use your camera for that, type a plus in chat, and thank you for being with us.
Yes, thank you, Sergey, for preparing this presentation. That was very revealing, and I think it's very...
Sorry for making it so that you...
No, that was nice, because this was, as you said, this topic, we're not experts in this topic. Somebody had to do the homework,
right,
to crunch it into, some lame terms, so to say. So you did a brilliant work there. For me personally, I think the one takeaway from this is really to ask about data sets. If somebody is telling you they have AI involved in something, LMS it is or a tool, just ask, where does the data come from? How has this machine learned? Who has learned that machine? So, and then it will tell you how much value is there and all in that, right? So that's a very, very
oftentimes AI is just a set of, AI is as a feature is just a set of rules and basic statistics.
If, then,
exactly. It's like, we do those intelligent guesses of the content that you will like if you like this content and so on. Well, that's just basic statistics that any internet shop can actually do.
Yeah, if you buy a phone, probably you also buy a cover for it, right? So it doesn't make an AI to decipher.
Right.
So thank you everyone for taking part in this breakfast. Don't forget to get in touch with us and suggest your own topics. As you can see, sometimes we speak from our experience, but sometimes we have to do some research from our hearts and minds in this case. This case is fine. Thank you very much for participating. And in 2 weeks, we're going to have the next breakfast, and we will inform you about the topic very soon.
Right. See you there.
See you there. Bye-bye.